Good morning, Professor.
Hello, Tamika. Sorry, I'm a little bit late. I was trying to find the boss. I'm not doing too good. I got a terrible toothache and I'm probably gonna have to get an emergency appointment. Hopefully I can make it through the class. All right,
Well,
PDF. To go. There we go.
we was on number 13 on page 4. You're welcome.
Because I'm. All right, here we go. Number 13. So y'all see the screen all right?
Yes.
Okay. All right, here we go. All right, so in finding the domain, generally for a function, you're looking at negative infinity to infinity. The only thing that's different is the logarithm, in which case you got to solve the inside of the logarithm to find out what makes it, greater than 0. So it's very similar here, because with this kind of square root, obviously it can't be negative inside. All right. So we got to take 6 minus 12x, and it's going to be greater than or equal to 0. It can be 0 here, unlike the logarithm. Oh, and then we can just basically add the 12x. And it looks like there's going to be a half. So
Yeah, it'll be a half. That's what I did.
yeah, x is equal to 1/2. Or x, I'm sorry, greater than or equal to 1/2. And I got it backwards, but same idea. It's x has got to be greater than or equal to 1/2.
So it was negative infinity
Wait,
times 1/2 with the bracket. Is that right?
let me check something. You know what? I just thought of something here. Because I got it backwards. I just want to double check. Okay, so that's right. So 1/2 is greater as. When these things are backwards, they can be a little bit confusing, okay? So it's actually, if you turn it around, and when you've got them backwards like that, you can kind of spin it, think of it like a weather vane or something on the flagpole. But as long as you keep the arrow pointed the same way. So yeah, I was right that I was looking at it backwards. Okay. So it's got to be less than or equal to 1/2. Because what's going to happen, essentially, if this thing, since this is a negative, so that's the problem. Hey, there it is. So this would be what it is.
All right, so the exam is Wednesday at 3:30 to 5, correct?
Yeah, all I got to do is go and look on the announcement because I got plenty of them. 110, 3:30, 5:30. So anybody out there that hasn't seen this, that's the date and time of the exam. Wednesday the 8th, 3:30 to 5:30 in room 110. Which I think that might have been our original room. So this is what it would be there.
we have a lot more people and stuff.
Oh, yeah, we got three of them like here. And then, I seen Helen in a couple of days and she's participating, so.
She was online, Tuesday.
Oh, she was?
Yeah, I think I've seen that.
Yeah, she was online Tuesday.
Yeah. I mean, I get worried about what folks and then all that shit, so,
That's it.
I mean, I'm afraid people are gonna miss announcements and stuff, and I got so little time after the fact, I can't just automatically accommodate people because they didn't know, because that's why we got these announcements, and technically, that's why we have class to go over these things. Okay, so this one, again, this is basically, a function that's gonna have an issue because of the denominator. X squared plus X minus 12 can't be equal to 0. So that means X plus 4, X minus
-3.
can't be equal to 0. So that's going to be -4. So X can't be equal to -4. Or X can't be equal to 3. So other than that, there are no limitations on this. So the way that that works is we'll just go down to -infinity, come back up to -4. We have to use the parentheses there because it cannot be -4. Over here, this can be 0, but that's the lowest that it can be. Wait a minute, I told you.
No, we use parentheses, yeah.
Yeah, I told you the parentheses and then I put a bracket. And let's see, it's going to be -4 to 3. And then a third one with 3 to infinity. Okay? Any questions about that? Oh, I had this and Lance was asking me about this at the end of class. Now, I feel bad because I probably didn't explain this well. This was going to mention maybe. Oh, it was like G. Because I neglected to say, when we, and I'll just show you on the graph real quick. So it's this one right here was the issue. All right. So kind of just make note of the fact that even though this is a +2, the shift is in the positive direction. And why is that? It's because we need to look at it like this. And if we look at it like that, which is essentially the same thing, then it makes a little bit more sense about why the shift is to the positive side. The negative side in here is what gives us the translation about the 2, or the vertical translation. The negative sign then reflects it across on the other side. But the thing that determines where it starts at, that starting point is 2, because with the negative sign factored out, it's x minus 2. So I just wanted to explain that because I felt like I stumbled over it when we did it. All right, let's see. All right. How many pages was it? It's not too bad.
I know we don't have,
I just, I had a hard time finishing the one from my 128 class, but it was a little bit longer. All right, so this is f of g of x. Another way of looking at that is this. So we're going to take g of x and stuff it into f of x. Okay, so see what I did? F of g of x.
yes.
All right, so every place that was an x now has an x plus 3. So we're gonna just have to go through and do the math. All right, so this right here is 2 times x squared. I'm taking that shortcut. And then this is minus 5 times x and minus 5 times 3 minus 15. All right, so then it's 2 x squared plus 12x plus 18 minus 5x. See, this is 15 and 6, so this is,
Minus 9.
all right, and so then 2x squared is all by itself. The 12x and the minus 5x give us plus 7x plus 5. Okay. This one is just the opposite. This is g of f of x. So we take f of x and put it inside of g, let's see. So the good part about this is there's only one x.
So it'll be 2x squared minus 5x plus 6 plus 3.
Yeah. So this is replacing the single x. Okay, so this right here replace the single x and add 3. So all we're gonna do is, I was expecting this to be a little more complicated. Let's not. Okay.
Yep.
All right, now I want to see another pair of these. I mean, that's essentially the same thing. Again,
So B, would B just be the 3 in the front? Then the x plus 5 minus 7, yeah.
but let's just set it up. So it's g of f of x. In other words, f of x is going inside of g. So 3 times square root of x plus 5 minus 7. So there's not much we can do there.
Right, it just stays that way, right?
Yeah, there's nothing we can really do.
Right, okay, I just wanted to make sure I had the right answer. So
Yeah.
we take the parentheses off or we leave the parentheses?
Well, and it's one whole radical, so you don't really need it. Like I said, I
Okay.
put it there because, you know, I just wanted to show that that's where the X was being replaced at.
Right, okay,
So this one really is not that bad either. This is just gonna be
yeah, that one was easy.
3x minus 7 plus 5. So we just end up being the square root of 3x minus 2. All right, so remember how to do the inverse?
Yeah, you put the Y and replace the X and all that.
All right, so we're gonna change spots. So this is X. And then this is Y plus 5 cubed. So see what I did there? I just replaced the X and the Y. Now I gotta solve for Y. So what I gotta do is I gotta take the square root, I'm sorry, cube root of both sides. So that cube undoes this one, so it comes out. So cube root of X is equal to Y plus 5. So then subtract 5. And there we go. Y or f of X. Okay. So this
Yeah.
one right here, again, Y is equal to 3x minus 7. And so we swap. So plus 7, so that's X plus 7 is equal to 3Y. And 5 divided by 3. So X plus 7 over 3 is equal to what? Okay. Oh no, I need to think about a word problem right now, but it's a rectangle, so we just got to remember that we're going to be dealing with a formula. You have 700 feet of fencing to enclose a rectangular garden. The garden will be divided into 2 smaller gardens by placing a fence parallel to one of the sides. It'd be nice if they give us a drawing. I'm terrible at drawing, but I know we had a drawing. Let's see if I can find one. Because it really helps. Like in the book and in the homework, they usually have a drawing. And it really helps. So it's something like this. Doesn't look very nice, but all right. We have 700 feet to enclose a rectangular garden, so that's a perimeter. the garden will be subdivided into two by placing a fence parallel to one of the sides. Parallel to one of the sides. Is this the one where you like have like a river or something on one side?
Yeah, yeah, it was like a river was on one side, but this one don't have anything
Yeah,
blocked
it
in.
doesn't. Okay, so this is very accurate then, okay? Because they're gonna have one here, so there's two. All right. So let's see how we can fix this. Express the area of the garden A as a function of one of this. All right, so let's just see what we can do. So we got 1,
Should
2,
be
3,
3 y to the third, right?
well, it's 3y,
Mm-hmm.
because we're talking about perimeter. 3y plus
And x,
2x,
2x.
right?
Mm-hmm.
3y plus 2x. And, well, it doesn't matter. I was gonna say we use W. All right. Now, we need to have one of them expressed as the other. In other words, let's solve this for x. Divide by 2. Well, that is it right there, 700. So that's it. That's the width. All right, so we're going to take the area. Remember, area is length times width. And that's what they want us to do. All right, so this one right here is essentially the width. Okay, so we're just going to do, it's just y times 70. Okay, so this right here was.
Where you got 70 from? I thought it was 700.
Sorry.
Oh, okay.
I just, see what I did, I miswrote it, and so I was transposing. So this is the area right there. They don't say to find anything, they just express the area of the garden as a function of one of its dimensions. I don't think the way to simplify it is not really. I guess we could do this.
So it wouldn't be, for x, it wouldn't be 350 minus 3y over 2?
Yeah. Okay, yeah, we can do that.
By dividing 2 into the 700?
Yeah, we can do that. Just this one is still going to be 3 halves. So then this would be 350y minus 3 halves y squared. Great. I was kind of surprised they didn't ask us to solve anything. Find the link, they just wanted us to. All right, so, all right, so you remember how to find the vertex? And it helps to have this written as in the ascending order. So A is equal to -1. B is equal to -4. C is equal to 5. You may not need that. All right, so this is X. So the X coordinate is going to be -b over 2a. Oh, and the teachers wanted me to tell you all about this. Tuesday, they used to have this before the COVID thing. And it's just like a tutoring, tutoring session. They'll have it here in the building, it's in the lobby from noon to 3. So I don't know what to show you out there in virtual land, but if you've been around, before COVID, we'd have these things called exam parties. And so teachers will show up and provide, help with it. They usually only have one table for each class. So, and they used to have pizza, but the lady, Miss Pam, she's the one who used to coordinate it. And she had a club and all that, they would collect dues. That's how they pay for the pizza, but without her, I don't, think there's a club anymore. All right. Okay, so that's the X coordinate. So to find the Y coordinate or the functional value, we got to plug it back in. Okay, so that's the vertex. Okay. We find the x-intercepts by essentially just solving. Well, actually, okay, what we can do is axis of symmetry is this. And x-ray, that's axis of symmetry. The domain is negative infinity to infinity. Let's worry about domains from this thing. The y-intercept is just the number hanging off the end. So the one that has the most work is the vertex and the x-intercept, because now we got to solve this, and I'm going to use the quadratic formula. So this will just tell us where Oh, wait a second. Still different. It's -1, all right. Okay. Minus 4a, this is a -2, okay. So that's 4 plus or minus. And that's 16 plus 20. But that's 4 times 5, and there's 2 negatives over -2. So that's going to come out perfect square.
How is it plus 20?
Because it's the -4 is built into the quadratic formula, and the a is -1. So -1 times -4 is positive. 4 times 5 is 20. That is when I wrote it and forgot to put in.
Oh,
that.
it is -1. I'm sorry. I see it now.
That's where I noticed that I had made the mistake that I had not made the negative. I put the negative there. All right. So 4 plus or minus 6 over -2. So that's going to be -2 plus or minus 3. So then what are they going to be? -5, -2 minus 3, and -2 plus 3 is 1. Okay, in the range, the lowest point is vertex. So -2 is the lowest going to come. It's going outside backwards. This one's going down. And it's coming up to -2. All right, so just look at this. Now that we got it, we can see how well we did on it. No, -2 is right. Oh, okay, I'm sorry, I missed stuff over here. Because when I put the -2 back in there, I put it in as a 2, I'm sorry. All right, because remember it was -2. All right, so let me fix this. +8. So that's +9. There we go. And also, I did back up now that I did, because I was thinking one more. The range is the y. So 9 is the highest it will ever get. So that was -5, that's the 1. Here's the y-intercept. Yeah, 0, 5. and the vertex is -2, 9. And 9 is the highest point that it's going to get when it's flipped upside down with that negative sign right there. Okay.
And how did we get 5 again?
Because that's, whenever you
What's
got a quadratic equation, if you put in 0, these two things right here are going to disappear. And the only thing that's left is the constant term 5 right there.
Oh.
Just like any other thing, but if you put 0 in there, you got 0 squared. If you put 0 there, you got 0. And so 5 minus or plus 0 is just 5. So when x is equal to 0, that's the definition of the y-intercept. So when x is 0, on 5 is the only thing that's left. And since it's turned upside down, that's the high point. You know, if we had one, just to kind of show you. I'll put another negative sign in front of this, just to flip it. See, then, if it were a positive one, in other words, it's x squared plus 5, 4x minus 5. See, it ends up being the same one. Oops. It's just turned upside down. And so here now is the low point of the vertex. And then this is the y-intercept down here. See, because it's the number hanging off the end. That's the y-intercept. And that's the same thing we do. When you're solving this for that whole thing, by putting in the quadratic formula, you are finding when y is equal to 0, what x is. All right, this right here is in a different form, so this should be easier for the most part. So the vertex is 5 minus 4. Okay. That means the axis of symmetry is also 5. The domain, like I said, for all functions except those logarithmic ones or things in the denominator is just going to be everything. And now what we need to do is we got to find the x and the y intercepts. It's a little bit harder with it in this one. You got the vertex handed to you. Okay, well, let's see. What is the okay, let's do the y-intercept. That should be easy. So that's basically going to be 25 minus 4, which is 24. So that's the y-intercept. Unfortunately for the x intercepts, I mean, unless something I'm missing, we just got to FOIL that out and write it in standard form. So we square that out. What you got? Now, I probably could have waited on the y-intercept because look at this. See, it's the number hanging off the end. So the same thing happens. Here, it wasn't easy to see, but once it's in that standard form, you see if you got it. Now, the only way to, of course, find the x-intercept is to solve this. This one is factorable as x minus 7 and x minus 3. So x is equal to 7, x is equal to 3. All right, now the range, highest point on the vertex or lowest point on the vertex, depending on how this thing is. This is a positive, so this one is going to be like sitting on the. See, this is what a positive one looks like. See, it's got the turnaround at the bottom. So this is going to be one where we take the functional value there of 9, and that's going to be the low point. Put it on here.
Why would it be 9?
Because that wasn't that the whoops, I'm saying, already I hit the wrong, I was looking at that. It's negative 4.
Negative, okay.
I don't know why I was looking at that. Thanks for negative 4. I just looked at the thing at the top of the screen, but I still had that there. All right. So if you want to just grab it just to see. Actually, I want to put it in original form. X minus 5 squared. So see that, there's your minus 4, the low point, and it's going out. Here's your 2 x-intercepts, and then your y-intercept will appear at 21. All right, so this is that multiplicity thing. So the way this works, if you remember, all right, the odd powers, and this is the thing what they call the multiplicity, mean that this thing crosses the axis. All of I'm going to do just a generic one, so we're not completely cheating. But see, all of the odd powers, they cross, and they got that same general shape. So no matter where it's 7, 9, 11, it's more or less going to do the same thing, but it crosses at that spot. So that's what happens with cubic, okay? And when that's a positive value, see, what is it? It falls to the left, rises to the right.
And if it's positive, it touches and turn around, right?
No, that's not, well, that's this. That's the basic quadratic does that. See, that's when the power is even.
Yeah, it touch and turn around, as they say.
Yeah, touch and turn around. And when it's odd, then it crosses. And if it's positive, in other words, there's no exit sign. See, it falls to the left, rises to the right. And then for the even one, it falls, let's see, rises left, rises right. Okay. So this right here has got that same basic shape of what we were just looking at, like that. All it's asking is just whether it crosses or turns around. So it crosses. This one touches. So this one crosses, this one touches. And this also flips it upside down. In other words,
Reflect.
yeah, reflect about the x-axis. So like we have that, see how it. So I'm not that one too much on those. All right, so synthetic division. Okay, now in my other class, these things took up some time, so we might want to be judicious about which one we want to pick. The one thing that I want, that's important to point out here is when you're talking about factors, you're talking about one thing, but when you're talking about zero or solution, you're talking about another thing. So what we got to do on this one is we got to use a -1 there. All right. If it were x minus 1, then we would use a 1. But for x plus 1, it's equivalent to x minus a -1. We got to make sure there's no gaps. In other words, there's no missing x terms. If there is, we got to put a 0.
That wouldn't be minus.
What
It would
happened?
be -3, right?
Okay, bring down the 1. -1 times 1 is -1. Oh, here, I'm sorry. So -1 times, so this is -3. And then this is 3. And then that's 1. And then this one's going to work. No, it's not going to work.
Excuse me, not to intrude or anything, but why is there a -3 in the middle of -9?
That'll be -8.
All right, let me just do a little thing what's going on? Okay, it's 1, -2, 4, and -7. There are no missing terms, so we don't have to put in a space over a 0. All right, so bring down the 1. 1 times -1 is -1. -3. 1 times -3 is 3. So that must be what you was talking about there, yeah. So this one. So it's no.
That'll be 1. Because you forgot your negative in front of the 3.
-1 times 7 is -7, right?
No, look. Negative, the -3 go underneath that 4, so it'll be just 1.
But it's -1 times -3 is 3. Here, right?
Oh, yeah, I'm sorry.
And then 4 and 3 is 7. -1 times 7 is -7. So this is -14. So no. And we can just say because there is a remainder. If it's 0, then we know it works. We know that it's a 0. So this is what this is saying. When it's given like that, then you use that value. That's the main thing that I want to point out here. When they give it to you as a factor, you got to add the negative sign. All right, so what this tells us that f of -6 is equal to 9. So, and the reason why this is important is just because I think that that's a lot less work than putting it in here and cubing and all that, squaring and everything. All right, let's see, what's on this next page? Because like I said, is if we got to go through the whole process, we may only have time for one of these. So let me see. Maybe that's a little bit good. All right, it's going to take a while though, because it's a slow process. All right, so we got to find all the zeros. So it's well, this one's not too bad. The one I had that the 128 people had was like 25 and 35. So this is just basically going to be and since these are all over 1, that's all there are. All right, so then zeros are functionally should be any one of these. So we just go through and do them. Hopefully. And these two things mean the same thing. It says find the roots, find the zeros. That means the same thing, okay? So we'll just do this one. All right. So let's just do order 1. And it's 1, 2. All right. So, and I consider it, I wonder what they come out. I mean, they had several of these. There was one like multiple choice, about find all the zeros, and then there was another one like this one. And I went through, I mean, like all of the whole numbers, and I still hadn't getting ahead. I kind of said, well, we're running out of time. Let's go on something else because the fraction is going to even take you time. So we know that one of them is 1 because it's a 0, right? And that means we've got that equation to solve, and this is easily factorable.
So it'll be 4 and -3.
Right. So the first one, it takes some, arm and hammer power to find it when it's a cube. And then after that, you can usually solve them pretty easy. Okay, so just make sure, because I noticed a few more people, or at least the one person come in. So this is still on, all right? Wednesday, December the 8th, from 3:30 to 5:30, room 110, all right? All right,
Can we do number 24?
all right, yeah, let's go on down and do it. All right. So the vertical asymptotes are what make the denominator 0. So this is x minus 3, x plus 3. So the vertical asymptotes are -3 and 3. All right. The horizontal asymptote is determined by dividing if they're the same. What is it? I gotta refresh my memory. I should have done this before. I did it last night and I already forgot what it was. There's 3 different scenarios. If you remember better, as it happens. So they're the same. So what happens if they're the same? I know that if there's a higher power up there, then there's a denominator. So let me just see something. Let's see if this is right. So I think that's y is equal to 1 because this is just 1 over 1. If I remember correctly. Okay. Let's see what else we got. All right, now. What this means is I might just go ahead and graph it out so you can see. But what happens is I'll just draw a kind of a sketch here. Here's your x is equal to -4. Well, they don't ask about that. All right, so what they're asking about is coming from this direction, the positive side, and this is talking about coming from the negative direction. And they're asking what's happening at this point. Now, if I'm not mistaken, this thing looks like this. All right. I mean, I know I can stick in values and figure it out, but, and that's probably the easiest way. It seems like there was a quicker way in the book. And, I'm just gonna keep some tones. Tell you what, I'm gonna use the calculator over here and figure out. This is the way I always remember doing it when I, just from my math days. Like I said, I'm not sure that they brought this up in the textbook or not. All right, but what I want to do is see, coming from the negative side, that's something that's like.
What about it coming from the positive side, the first one?
Well, then that would be 3.1, let's just say, put it in 3.1. So I'm just gonna get this calculated. And then it's, so that's 15. So it looks like to me it's getting higher. Let me just put one more. Yeah, let's say I put it in 3.2. That'll give us an idea of what's happening. So getting farther and farther on the positive side. All right, so it's getting, yeah. So this is what it's doing. I was guessing about this. So this is what it's doing on this side. Because as you're getting closer, it's getting higher. All right, so likely then this one's going to be doing this. All right, so as it gets from the positive side, it's going to infinity. And then on the negative side, it's going to negative infinity. So that's the way it is. So as x is equal to infinity, it's going to be doing the same thing over here. It's both of them are 0. Let's graph it and let's make sure. That didn't give you a little more. And I'll put in the so see, as it comes on the positive side, it's going up. And as it's going on the negative side of 3, it's going down, just as we said. And then they said, well, as x gets to infinity, well, f of x is getting closer and closer to 0. These things are going to keep on going and getting closer and closer to 0. Oh, you know, I'm sorry. I forgot about this other thing. That was the horizontal asymptote. So that's what it's getting close to. I'm sorry, because it's bumped up 1. There we go. It's not going down to 0, it's going towards 1. And that was what the horizontal asymptote is. All right, so does that make sense? I know a bunch of that one we get to this. I just can't remember if they threw it, if that's the way they did it with a test point. To me, that's the easiest one to do, is when you got one of these rational things like that. As you go just a little bit on the positive side, put in a value, maybe pick another one a bit farther away, and then you can tell that it's getting real high over there. And if we had put in 2.9 over here, it would have gone down to negative something or other. And then there was the horizontal asymptote. Well, let's do one more thing. Okay, so it said if m is greater than n on that second one, and it's not. So this right here, it's a zero asymptote.
These are gonna be hard to do without a graph.
Yeah, it is, but you can recreate the graph, like I said, sort of like this, because you draw in your asymptotes, and I neglected to put in the horizontal asymptote. This takes time. I mean, that's just no way to do it, and I'm just trying to cram it in here. But just remember, you're not going to have this many of every one, okay? Like I said, we didn't get to the end, but there's probably like, I don't know how many problems, 40 problems. So usually what the number of problems they have is like 25 to 28 or something. So they're probably going to eliminate the ones that were doubled. But if you need help with any of those other ones, let me know, and I'll write them up and send them to you. Okay? Any nice questions? Like I said, remember this thing here, this what they call it. I mean, they call it a exam review party. Be Tuesday, and that's after classes. So that's the day usually like English tests. So you should be able to go over there. All right, we'll see you next Wednesday, okay? Don't forget
Thank you,
that.
Professor. Thank you, Professor Cruz.
All right, bye.
Mr. Cruz,
Yeah,
I have a question.
good.
So you saw my emails to you asking about the test, and now I have just one last question in regards to the final. Is it multiple choice? Is it fill in the
12 multiple choice, and then the rest of them will be, free response.
Okay, so you just write down the answers.
Yeah, and you can get partial credit on those.
Okay,
I'm grading them by hand, so if you're more or less doing the right thing but made a mistake, you can get half credit on those.
okay. All right, I was just curious about that.
Yeah,
Bye-bye.
that's the way it works. 12 multiple choice, and then the rest of them are free response. I think there's usually like 14 of them. About half and half. All right, anything else?